All right, we will be looking at the integumentary system today. So, first part is just going through some of those key features, looking at some of those specialized cells that we're going to see here, and then identifying our various layers and looking at how those layers are created. So, first thing, this is going to be our keyword. So, integumentary, this is going to be relating to external covering. So, there's going to be hair, skin, and nails in this unit. So for functions, first things first, protection. So our skin we know is an external protector against the environment. And so this is going to be our first defense against any foreign objects, pathogens, or anything that is trying to harm us. We will see that we also have temperature regulation here. We've talked a lot about homeostasis and about how our skin is responsible for helping maintain some of that heat loss or heat preservation that may happen. We may see things such as like an increase of blood flow to the surface of the skin or a decrease depending on if we are too hot or too cold. Looking at our excretions, so these are going to be typically our exocrine glands, so looking at our sweat and oil glands, seeing how these materials are secreted through the skin to help either cool the body or remove any excess waste in the system. Next is vitamin production. Now, we will talk about this when we go over melanin. So, this is how we are using those epidermal cells to synthesize our vitamin D. And then the last one is our sensory reception. So, how are we interacting and understanding the external environment, and what components are allowing us to interpret that environment correctly? Is this something where we are putting our hand down and we're saying that is cold or hot? Or is it something that's a little bit more intrinsic and is giving us, is something wrong? Is something not wrong? All right, so we have three layers of the skin. So the first layer is going to be the epidermis. Now, the epidermis, that is going to mean above, so our above dermis layer. So this is made up of thick epithelial cells. We're going to see a lot of stratified squama, and we will see our keratinized and non-keratinized here. Next is going to be our dermis. So our dermis is going to be lots of our fibrous CT. And we will see that this will be typically the thickest layer. So we're going to have lots of blood flow here. We're going to have some of our exocrine glands here. We will also have things such as our hair follicles beginning in here. And then our last one is our hypodermis. So hypo is going to be below. So this is below the dermis. And this is going to be primarily made up of loose areolar tissue, or we may even see areas of adipose tissue, that fatty tissue that's going to help insulate and protect some of the underlying areas. So the first cell we will look at is our keratinocytes. So these guys are very important. We have talked about keratin quite a few times already in passing. So keratin is going to be a very tough fibrous protein. This protein will oftentimes be secreted into our squamous cells as they are aging and moving up to the external layers of the epidermis. So what will happen is typically as our cells are aging, our squamous cells, they are going to get small amounts of keratin that is going to be secreted from those keratinocytes. This is going to cause them um, to fill that cytoplasm up our with our keratin, and then that's going to allow them to become a protective barrier that will then get sloughed off due to abrasive nature of the external environment. So we will see that this is going to give our epidermis a mechanical and physical protection. We will also see that our keratinocytes do play a pretty good role when we talk about immune defense. They do produce antibodies and enzymes, and when we talk about skin having its own microbiome, these are usually part of the reason for that. So these guys will create different material to help break down any possible pathogens that the external environment's throwing at us. Next is going to be our desmosomes. So this is a very important word. Keep that one in mind. There is a free response question that is on it, and you will see it on the multiple choice. So desmosomes are going to be basically glue, protein glue, that's going to help hold our cells together. Now, we will oftentimes see that our keratinocytes are going to be attached by those desmosomes to our squamous cells. So making sure all of that material is holding together and we don't have cells kind of floating around, right? Now, a really great image right down here. If you look at this, this is showing the aging process of those squamous cells. So we go from the young cells at the very bottom of the epidermis, and as we are moving up to that top layer, we are seeing that those keratinocytes are starting to begin to harden, get in that keratin amount as they are meeting that old age requirement or being secreted out to the top surface. Those cells are usually dead and are going to contain large amounts of keratin. So we now are going to call them our keratinized squama. All right, really great photo showing the difference of your keratinocytes and your desmosomes. As you can see, those keratinocytes are pretty big cells, and then those desmosomes are going to act like little glues that are going to hold those cells together with the squama. You will see that those desmosomes do have a similar structure. They kind of look like intercalated disc, but instead of obviously being in a muscle fiber, they are in a squama-based tissue. Next are melanocytes. So these guys are going to create the pigment melanin. Now we will talk about two types of melanin. The first one will be eumelanin, and the second one will be our pheomelanin. These guys are going to make up about 10 to 20% of stratum basal. So that is going to be our lowest layer. So that will be the layer that exists right up against that dermis. These guys are going to have a spider shape to them, so they have lots of little areas that kind of stick out, and so they kind of look like little spider legs that are sticking out. And let's get our pen ready. All right, so next one is our dendritic. These are also known as the Langerhans. So Langerhans, dendritic, these will be used interchangeably. Be aware of both of them. So Paul Langerhans was the guy who originally discovered these cells, and they do have a really beautiful little star shape. I think that they are super adorable. But Paul Langerhans originally saw these cells and were like, man, these guys kind of look like the dendrites that we see on our neurons. So he gave them the name dendritic cells. Now, obviously, time goes on, technology improves, we learn more and more about the world every day, and so we realized that instead of these being nervous cells like he originally thought, they ended up being immune cells. So these guys are part of the immune system. They are really important when we talk about being antigen presenting cells, meaning that they are going to pick up a pathogen and they will then go to somewhere in the lymph system, usually, and they will present that pathogen. Say, hey, I have found this, it is trying to invade our human, and I want to make sure that we are protecting against it. They are also going to be a type of macrophage. And so we will just put that right here. So think of our macrophages when we talked about them last unit. Our macrophages are a little Pac-Man. So these guys do have that ability to engulf or consume other cells. We will see that our dendritic cells are going to originate in the bone marrow just as many of our immune cells do. When we talk about our white blood cells, B, T cells, all of those guys come from the bone marrow, which is where our blood cells are produced. These guys are no different. They will also come from that same region. All right, next is going to be our tactile epithelial cells. These guys are also known as Merkel cells, so be aware these are interchangeable names. They will be used interchangeably. So our tactile epithelial cells, Merkel cells, these guys are going to be responsible for our ability to process what we are sensing in the environment around us. So, in areas where we are encountering a lot of sensations, so places such as maybe the lips or the face, in the hands and feet, we are going to have high concentrations of these tactile epithelial cells. Now, I always like to think that tactile is a really good giveaway as to what they do, right? So I think tactile, I think of touching or maybe grabbing things. And so that is going to give us the ability to understand what we are touching. Now we will see that these tactile epithelial cells are going to exist very close to our nerve endings. And so what they are doing is they are receiving information and then they are going to pass that information on down to our nervous system to then allow us to figure out what are we sensing, what are we feeling. All right, so we're going to do a little quick review on our different cell types here. So for our first one, these are keratinocytes. So these guys are going to be located in all layers. So when we talk about the epidermis, we will talk about the 5 layers in our thick skin, and then our 4 layers in our thin skin. We will see that obviously keratinocytes, they are going to be responsible for keratinizing those stratified squama, and so we want to have them in every layer as they start to build and fill that cytoplasm with the protein. So primarily our function here is going to be for protection. We want to ensure that we have a nice rough surface that can handle abrasive interactions with the external environment. And then we will also see that is going to act as support. So primarily our support is going to be in relation to that slight immune relationship that they have. So we know that they are not the they are not the most impactful immune response, but they are some of the first immune responses that we're going to have. Our next one is going to be our melanocytes. So melanocytes are going to be found in the stratum basal, and this is going to be the lowest layer of the epidermis. So this is right next to the dermis. It's our very last layer, so our deepest layer. We're going to see that the function here is going to be creating our melanin. So this is going to be 2 types, either our pheomelanin or our eumelanin, and we will talk about those next lecture as well. Now with our pigmentation that is being created here, we will see that they create that pigmentation and then use an organelle known as a melanosome. Now this melanosome is going to act as a carrier and move pigmentation move pigment into our keratinocytes. And that is going to be how our squamous cells are going to get their pigmentation. How are they going to get their color? Our next one is going to be our Langerhans cells. So be aware, remember our Langerhans cells had a additional name, and that was our dendritic cells, because of their shape. They kind of have that similar shape to the dendrites that we see in the neurons. So these guys are going to be located in the stratum spinosum. So stratum spinosum, and we'll see if I spell this right. Close enough. So these guys are going to be immune cells, and their whole job is going to be consuming and preventing infection. So again, we're going to see those macrophages being able to engulf and consume foreign material or pathogens and bringing it to the lymph nodes for waste disposal. So remember, our macrophages were our little Pac-Man of the body. So think of them chasing those little dots, those little white dots, and then think of those little white dots as being anything that's foreign trying to attack their human. All right, our last one is going to be the Merkel cell. Now, the Merkel cell also had a alternate name, and that was going to be our tactile epithelial. So that tactile, think of touch, and this guy is going to be located in the stratum basal. All right, so these guys are touch stimuli. So they are going to give us a insight into what is around us. We will see that they are going to vary in density due to our location. So areas such as the hands and mouth are going to be much higher than other areas such as maybe arm or leg or stomach. Not saying that you don't have a lot of sensation there, but it's a lot of your readings and a lot of what you're interpreting from that external environment is coming through usually the hands, feet, and mouth. All right, so moving on, we are going to look at the 5 layers. So we're going to go from the superficial, so the outermost, to the deepest layer. That's going to be right above the dermis. So for our epidermis, the first layer is going to be our stratum corneum. This is also known as the horn layer. It gets its nickname as the horn layer due to the fact that we have keratinized dead squamous cells. So these are going to be keratinocytes that are very hard. They're going to be full of that protein keratin, and so we can see that they're going to help protect against any kind of abrasion or things that may be trying to penetrate. Now, obviously, we know it is not very hard to cut the skin, especially if you are getting something such as a paper cut, but most of the time, this horn layer is going to help protect from smaller microbial microscopic material. We will see that the horn layer is going to have lots of glycolipids that are going to help waterproof it. So that's going to allow us to prevent water loss and dehydration through the skin. Cells here are going to be shed regularly. So typically during the winter months, you can really start to see some of those cells build up, and that's where we kind of get that ashy area. You know, sometimes we need to put something on to keep our skin nice and moisturized, but these cells, regardless, are going to shed. A lot of times you will use like something to exfoliate to make sure that you know you're not having a buildup in one location of those dead skin cells. Next is going to be the stratum lucidum. So this is going to occur only in thick skin. So keep this right here in mind because this guy is not present in our thin skin. And this right here should say thin skin, not thick skin. Just pretend that little K right there doesn't exist. So in our thick skin, we have 5 layers. In our thin, we only have the 4. Our strataluciderm is kind of like an extension of the stratum corneum, which is our horn layer. So what we're going to see is that we have a very thin layer. It's only going to have a couple of rows of those flat, dead squamous cells that have been filled up with keratin, so flat, dead keratinocytes. We will see that when we look at this material on a slide, it's kind of hard to sometimes see the difference between the corneum and the luciderm just because their composition is so similar. Now, when we look at areas of thick skin, so thinking palms of the hand, soles of the feet, places are going to get a lot of contact and possibly abrasive contact, right? Like we pick things up, we need to be able to hold things without our hands hurting or that skin tearing off. And so that strataluciderm just adds a little bit more protection in case something happens to that stratum corneum. So when we talk about walking around without any shoes, that luciderm is going to ensure that if we step on, say, a piece of mulch, it's not going to penetrate through our foot. All right, our next one is our stratum granulosum. So this is going to consist about 1 to 5 layers of our flattened keratinocytes. Now at this stage, they're in about the middle ground. So they are still alive. They are still trying to attempt to regenerate, but this is where we start seeing that cell death occur. So when you look at these underneath a scope, you may still see living healthy versions, especially on those lower layers of the keratinocytes. And then as you start moving up closer to the first 2 layers of the corneum and the lucidum, you're going to start seeing some of those cells die off. These guys are going to contain prekeratin filaments. So these are going to be known as our keratohyalin granules and Lamar granules. Be aware of both of these. These were a FRQ question last year. There is also about 3 questions in the bank regarding these little guys right here. With our stratum granulosum, again, seeing that regular cell death. Now, as we are moving up in the epidermis, we are losing access to that blood flow, which means that we're no longer getting the same amount of nourishment that we are in the lower layers. So typically that granulosum, as we're seeing that cell death, it's just because we're moving away from all of our nourishment or healthy blood flow that may be supplying us like lots of life. Next one is going to be our stratum spinosum. So this is going to be a pretty thick layer. We're going to see that these are going to kind of bundle up and create almost what looks like fibers of cells. And we will see that these guys are going to have very high tensile, so high tensile strength, right? We talked about that being very tough if you pull it. And we will see that we're going to have lots of that prekeratin protein here. Now, these cells are still 100% alive. They're healthy. They're still doing their cellular division of mitosis, and they're still trying to complete their life cycle. In this stage, we see lots of keratinocytes and lots of dendritic or those Langerhans cells that are going to exist in this region. Now, as we move down to our very last layer, this is the stratum basal. So this is our deepest epidermal layer that we have. It sits right on top of our dermis, and this is going to be a single layer of cells. Typically, all of the cells here are going to be stem cells, meaning that they haven't differentiated into their job type. So some of these cells are going to become keratinocytes, some of these cells will become um, our melanocytes, or some of these cells may become our dendritic cells. They just haven't figured out what their job is yet. Now, our melanocytes are going to exist in the stratum basal, and we will see that as they begin kind of finding their specialization from being a stem cell and determining if they're going to be a keratinocyte or a dendritic cell, those melanocytes will use those melanosomes to insert that pigment into the cell. So that way, as it grows up, and moves throughout the cell layers to the big world outside, it will maintain that pigment along the way. So whether it's that eumelanin or that pheomelanin. All right, so looking at our thick and thin skin. So thin skin, just as a quick recap, is only going to contain four of those layers. So stratum basal, spinosum, granulosum, and corneum. And then our thick skin is going to be all five layers. So we have our basal, spinosum, granulosum, lucidum, and corneum. I would highly suggest to either look up a really good mnemonic or create one yourself to remember the difference between the thin and the thick skin. There's plenty of them on Google, and also figure out that you know or determine when you make your mnemonic which way you're going to remember it. However you remember it, as long as it's in the correct order, is fine by me. But some people like to memorize it as superficial to deep for their mnemonic, whereas other ones like to go from the deepest layers to the most superficial. Just be aware that you know, like stratum basal is your deepest layer. It sits right on top of the dermis, while our horn layer or our corneum layer is going to be up on the surface. All right, so moving into layer two, this is the dermis. So this is going to be our area with flexible connective tissue. So we have lots of connective proper tissue that's going to exist here. We will see that our dermis is going to hold our epidermis and the rest of our body together. So when we look at the dermis, a lot of times, if you look at the etymology of words, our dermis is actually going to be derived from a word that in origin corresponds to talking about animal hides. So when we are looking at maybe tan skin, maybe you have a leather bag or a leather purse, and you are looking at that material that we have tanned and turned into a product is the dermis of that organism, so the dermis of that cow. Be aware that the dermis is a very strong material, right? So we know that leather is very, very tough, but it is also a material that even after it has been tanned, still needs a good amount of moisture in it. So if you have a leather belt or a leather bag or a leather jacket, you know that sometimes you'll have to put leather conditioner to maintain that stretchiness. And same thing here with the dermis. Obviously, with the dermis being on the internal of the body, it's not going to dry out the same way a leather bag does, but it is something to keep in mind. So the first layer of the dermis is going to be the papillary layer. This is going to be made primarily of our areolar connective tissue. So we have very thin collagen and elastin fibers that are going to exist here. It's going to make up about 20% of our dermis. Be aware of that percentage. That was a multiple choice question last year, and it was one of the possible answers for a free response as well. This is going to contain something known as our dermal papillae. So this little guy right here, we will see some images, especially when we get talking about like protection of the skin. These guys are basically going to be projections that are going to extend into the epidermis. So this is going to be how that dermis is going to exchange nutrients such as gases or remove waste from the epidermis. When we talk about those cells dying, there's material that is secreted that has to be cycled back through the body. So these projections here are going to be able to pull that material from the epidermis, send it back through the system, and correctly process it through the lymph system as a waste product. We will see that the projections here will also strengthen our dermal and epidermal junctions. So that means that these are going to be areas where we have a lot of adherence. And this is also going to help reduce blistering. So in normal conditions, if you have abrasive nature along the epidermis and the dermis, we typically will not have a blister. Now, if you get a blister, that is because you have had excess amount of friction occurring in that region. So most people oftentimes get blisters from the back of their shoes on like their heel, or we may also see if you're in something such as baseball or softball, you may see some of those blisters occur if you have like a new set of gloves that you're wearing. So you may see them occurring in between the fingers. All right, next is going to be our reticular dermis. So this is dense, irregular connective tissue. Now, remember, our regular tissue is going to be irregular because we're layering it in a perpendicular fashion. So every other layer is going to change orientation. This is going to make up about 80% of our dermis. Be aware of that number again. Know that 20 is our papillary, 80 is our reticular. This guy is going to have very thick and large bundles of collagen and elastin fibers, and we will see that these create something known as cleavage lines. So be aware of cleavage lines. We will work with these in class, so you will see them. These right here are cleavage lines on this model. So you can see all of the areas where skin typically folds. This is due to the amount of tension from that tissue. So when we are looking into things such as surgery, there are certain ways that people want to cut the skin to ensure that we are going to have minimal scarring, or we are going to have the least amount of fibroid or fibrosis occur, especially if somebody is prone to developing things such as keloids, where they may have had surgery and we have an excess production of that scar tissue. We want to ensure that we are cutting along those cleavage lines. So when you have a surgery, a doctor will typically try to map out a region to cut, and they are not just drawing on you, they are actually trying to follow some of those natural areas where that tissue is going to fold or lie in between. So in the limbs and head, we're going to see that those lines run longitudinally. The neck and trunk are going to have circular patterns. And then we're going to see that some of the areas, obviously like the armpits, those get a little bit difficult because that is going to be an area where a lot of tissue is folding over on one another. So if you're ever having like a surgery or a piece of tissue that is being biopsied or removed in the armpit, you will oftentimes see a plastic surgeon be brought in because we have a lot of tension lines that are kind of overlapping on top of one another. We can also see it here in the hands too, right where the end of the thumb is. Now, our reticular dermis is going to have really great stretch and recoil properties, so that allows us to stretch that skin without having extensive damage done. So that skin's able to bounce back to its original position for multiple times. We can also see that when we talk about weight gain and weight loss, this reticular dermis, that stretch and recoil is very, very important. We will also see that in certain circumstances, collagen can be torn when we have, usually it's in terms of like large amounts of weight gain. So when we see people who are pregnant, they may have some white scarring, there are little tiger stripes that occur, and these are going to be known as striae. So be aware of this word. It is a very fancy and technical term for stretch marks. So what we will have or what we will see happen is that this area is going to get so stretched out, especially when we talk about those big pregnant bellies, right? That skin is being pulled way past its limit in a very short amount of time. And so that collagen is actually going to tear and not be able to replace itself in the same fashion that it was before. So that gives us our little stretch marks. All right, next is our hypodermis. So this is the last layer of the skin. This is made up of areolar and adipose connective tissue, and it is also known as the superficial fascia or the subcutaneous layer. So if we were to break these words down, superficial fascia, we talked about fascia being a material that's going to help connect organs or connect material together. So areas of such as tissue or organs to maybe help hold them in place to an abdominal wall. So this is going to be the outermost or uppermost layer of that. And then our subcutaneous, that is going to be below the skin, right? So below that cutaneous membrane. We're going to see our hypodermis is going to store fat. We need fat for insulation. We also need fats and lipids for nerve control. And we will see that this hypodermis will help anchor our skin to the rest of our body. So it's going to help attach it to areas such as like the internal lining of our cavities, and making sure that that skin is not sliding or moving all over the place. So this is going to attach mostly to muscle in majority of regions, but we can see that it attaches to some of that excess fascia that may exist, especially around like the cavities. Our attachment here is going to be relatively loose, but it is not going to be loose enough that the skin is going to be able to move entirely separate from the material under it. So we will see that the skin is able to slide over that underlying structure, but it's not going to completely separate. So think of it as wearing a nice, well-fitted shirt. Kind of you have enough room to move, but it is not super tight that's restricting, but not too loose to where like you throw your arm up and the whole sleeve falls down. Our hypodermis can increase with weight gain and weight loss. This is going to primarily occur in two regions based on the male or female. So in our males, our subcutaneous fat is going to primarily occur in the anterior abdomen. So that's going to be areas like a little beer belly. And then in our females, subcutaneous fat is going to be stored primarily in areas such as the thighs, the butt, and breast tissue, and also into some of the breast tissue that actually exists in the armpits. So if you ever see like that little excess of bit of tissue that may be in the armpit, some people get really upset with it. That is all just excess breast tissue that that adipose tissue is going to be stored in. All right, so doing a quick little content check. So here we have both a drawn image and um, a slide of our 5 layers for the, let me fix my pen here. All right, so these are going to be our 5 layers of our thick skin. So our first layer that we are going to look at is going to be our stratum basal. Now our stratum basal is going to exist on the very bottom of the epidermis, so it's going to be right on top of the dermis. So it's going to be all of these really dark purple cells are going to exist right here. And we can see that it's got some of those melanosomes already existing. So I'm going to do a really terrible job at outlining this, but hopefully it is good enough to be able to differentiate. So this right here is going to be our S basal. Now, if we were to look at our slide image of it, our basal layer is going to be all right here. So we'll go ahead and come in from this side as well. And we're going to see some of that basally layer, and then it's going to connect all the way through. And then right underneath this is going to be all of that wonderful dermis and connective tissue that we learned about last unit. So this is going to be S basal. All right, our next layer is going to be, and let's maybe do something, okay, a little bit different than red. So next layer is going to be our stratum spinosum. So this is going to be an area where we still see a lot of those living cells. So they have differentiated in the basal layer from their stem cell phase. They've determined if they're going to be a keratinocyte, which are our squamous cells, if they're going to be a dendritic cell or something else. So these are all going to be located right here. So all of these nice, beautifully lighter colored purple. Now, luckily, this drawn image is really easy to see the difference, but in our slide image, it's not necessarily as easy. Obviously, you guys have been practicing with your histological images, so some of you may feel like a pro, some of you may not feel like a pro yet, and that is totally okay. So we're just going to roughly outline where this would be. So it's going to be all of that lighter area. Now you will notice that some of the cells do look a little bit different. So they're not picking up as much dye as some of our cells in the basal layer, and that is just going to be because of them differentiating. So they are no longer stem cells, they're slowly becoming either those keratinocytes, or they're becoming our dendritic cells. So spinosum right here. All right, our next one, let's do the granulosum. So this is going to be layer 3. Now, granulosum in this one, obviously, the illustrated image makes it very easy to see, and this dark blue doesn't make it too easy to see. So right there, so our S granulosum. And then on this, I kind of covered it up a little bit, but this will be all of our granulosum right here. And that's very difficult to see. Granulosum. All right, and then let's do some orange. So next is going to be our stratum lucidum and then our stratum corneum. So remember, our lucidum is only present in our thick skin. So it is that one that is kind of the odd one out. It's this light purple portion here. So we'll do this. And then in our image, it's going to be that very thin purple layer that's going to exist right above the cells of the granulosum. They're kind of difficult to see with the drawing with the pen on them. So we'll do that as stratum lucidum. All right, and then our very last layer is going to be, let's see, let's do this. All right, so this will be our stratum corneum or our horn layer. So this is the outermost layer that we have. Obviously, this is going to be the region where we see all of the abrasive keratinocytes. Remember, they've got to have lots of protective capabilities to be able to protect us from all of those pathogens that want to make us sick. So stratum corneum, and you can kind of see in the image here where they get their nickname as the horn layer, because some of those cells do not lay perfectly flat. They kind of stick up like little horns. All right, so that is all 5 layers for our thick skin. So we'll just title this, so thick skin. All right, so moving into our next one. So these are going to be our layers of the thin skin. So we are still doing 4 layers. So we're going to begin out with the easiest layer, and that is going to be actually, let's do a darker color here. All right, so our first layer is going to, nope, we'll actually stick with the green. Our first layer is going to be our stratum basal, and again, same thing as before, those really, really dark cells right there. And again, just horrible outlining, but you know, you get the point. So stratum basal here. And then if we look, this image is actually super duper clear of where that stratum basal is, and I really do appreciate how nicely these cells are organized. So S basal. All right, for our next one is going to be the stratum spinosum. So same thing as the previous layer, it's going to be these darker ones right here. So if we follow through all of these nice little guys right here. And then if we look at our image over here, stratum spinosum is going to be all of these right in here. So right under that deep purple line and right above the cells of the basal layer. All right, next is going to be our stratum granulosum. So remember, this is that kind of weird layer where we start seeing some of our cells are still alive, some of them are kind of starting to die off, and that's going to be that darker purple region. And then in our image right here, it's going to be some of these darker cells that are going to exist. So these kind of little maroon cells here. And then our last one is going to be our stratum corneum. So again, our little horn layer. So this guy is going to be right here on top. He is probably the easiest to see out of all of these. And he will be our last one. So stratum corneum. Now, fun little thing just to kind of show you guys. So if we were to look at where the melanocytes, because we do have a couple of them hidden in here. So our little melanocytes are going to exist in this image. They're the little white colored cells right there. And in our image here, they're actually going to be the little light colored cells as well. So really cute, really easy to see once you start getting the hang of it. So I will see you guys for the next section of the lecture. Hope you all